Hi everybody, welcome back from ClickTalk Engineering Open Lecture Series. My name is Damien Tyke. I'm doing Open Lecture Series in Mechanics subject. And for those of you who are watching this video for the first time, we are doing Open Lectures in Mechanics because it's important fundamentals for engineering, and also of course those of you who are sitting A-level exam. So today we will look at two things, and the first one is the free fall motion, and of course the velocity. We have already discussed about this in the previous video, but I will just recall this because in the next video we will have a kind of radical experiment to measure the velocities and the acceleration due to gravity, which is the value of g from the free falling motion. So today we have two things: the velocity in free fall, and we will derive the equations for the gravitational acceleration using free fall theory. So basically we are looking at two things, and as I have said earlier, in the next video we will be showing you a practical experiment to measure the value of g from the experiment. So please subscribe to our channel and study closely. So now we will just quickly start with the theory first in this video, and as I have said earlier, in the next video you will learn about the experimental measurement about the value of g. So now of course we have the free falling motion. So your particle is initially at position 1, and then it falls to the ground at position 2, and of course as you see in the figure, at position 1 we have the object above height h from the ground, and because it's just dropping, and at time t equals 0, the initial velocity u is 0, and then the object will just fall down to the earth under the influence of g, and of course g is vertically downwards, and as a result the object will accelerate because the motion direction, which is the direction of the velocity, is vertically downwards, and this is the same with the direction of the acceleration. So the object is accelerating, and now position 2 is just before the object hit the surface of the earth. So of course at this point the velocity will be maximum. So this is about the free fall, and those of you who have followed our video lectures closely, you know for free fall the type of motion is constant acceleration, and u is equal to 0, acceleration equals to positive g. And those of you who have not learned about that, you can watch our previous videos, or of course you can just read your textbook in physics or mechanics, right? So let's first try to look at the velocity. So the velocity at any time t in the free falling can be found by constant acceleration equation, which is just v is equal to u plus at, and of course initial velocity u is 0 and the acceleration is g. So we have the final velocity v is equal to 0 plus gt, and then your v will be just equals to gt. So please try to remember this equation, v is equal to gt, for the free fall, because we are going to use it later. And now the same problem where we look from the energy point of view. So we have the potential energy, which is just the gravitational potential energy when your object is at height h. And those of you who are not familiar with the potential energy yet, so don't worry, please just follow with the discussions in this video. For those of you who have already know, of course, that is really good. So potential energy in short form is PE. So this is the gravitational potential energy. When your object is at a certain height h from the ground, your object possesses the potential energy, which is just mg times h. So this is the formula that we will use to find potential energy, mgh, right? So potential energy is of course proportional to your mass and the height, the location of the object above the Earth's surface. And of course, we also have the acceleration g here. And the next is kinetic energy. If your object is moving with velocity v, your object also possesses the kinetic energy ke, which is just half mv square. So kinetic energy is directly proportional to the mass, and it varies with the square of the velocity v. So those are the two equations that we will use for potential energy and kinetic energy. And when your object is moving, your object will have both the potential and kinetic energy at somewhere along if its movement. But now in this particular case, we are just interested in finding the total energy at position 1 and 2. So let's look at total energy at position 1. So at position 1, your object is at height h, so potential energy is mgh plus kinetic energy is half mv square. So at position 1, the velocity is u, so you have half mu square. And since your object is at height h, your object will have potential energy mgh. Since the value of u is 0, your object will have no kinetic energy, so ke will be just 0. So you have the total energy at position 1 will be just mgh. So this means at position 1, your object only have the potential energy mgh. There's no kinetic energy. And now let's look at the total energy at position 2. So the formula is just potential energy is mgh plus kinetic energy is half mv square. But at position 2, your object is touches the ground already, so the height h is 0, so you have 0 potential energy, and the object moved at velocity v just before it hits the ground. So the kinetic energy is half mv square, and as a result, you have 0 potential energy, and the kinetic energy is half mv square. So this means the total energy at position 2 is just half mv square. And now we were trying to look at those energies at 2 positions by the law of conservation of energy. And of course, I think everybody here is aware that the law of conservation of energy states that energy can neither be created nor destroyed. Energy can be transformed from one form to another, right? So by the law of conservation of energy, total energy at position 1 must be equal to total energy at position 2. So total energy at position 2 is just equals to total energy at position 1. So at position 2 is half mv square, at position 1 is mgh. So you will have half mv square equals mgh, and of course the mass will just cancel. So your v square will be the half factor. If you move to the right side, you are multiplying with 2, so v square will be equals to 2gh. So now if you look from the law of conservation of energy point of view, you have already proved that the velocity square is just equals to 2gh. But you also have the velocity information from the constant acceleration motion, so which is just v is equal to gt. So v square will be just g squared t square. V square will be just g squared t square from the kinematics, right? So the kinetic energy from the kinematics is just v square is equal to, sorry, the velocity square from the kinematics is just v square is equal to g square times t square, and from the energy point of view, v square is just 2gh. So we just can equate the two of them. So g square t square equals to 2gh. So of course, 1g will cancel out. So you will have g on the left side, and t square if it moves to the right side, so we will just divide. So 2h by t square. So you will have the equation for acceleration due to the gravity, which g is equal to 2h by t square. And this equation can be used to find gravitational acceleration g equals to 2h by t square. Now, of course, theoretically, you know the value of g is 9.8 meter per second square, as obviously founded by the scientist and physicist. So this is the way we derive the acceleration due to gravity from free fall, looking from the kinematics point of view and the potential energy point of view. So if you look at this equation, there's one particular advantage of this equation, because if you look at the value of g can be just found by 2h by t squared. All you need to know is the height that your object has fallen and the time taken for this free falling motion. If you know those two of them, you can just find the value of g without having the information about the velocity. So that is really quite good, because you can find the gravitational acceleration without any knowledge of the velocities. And of course, in the next video, we will show this the experiment, how to measure the value of g, and of course we will compare the value of g with the value in the literature. So stay tuned and see you in the next video. Bye bye.